In this video, we're going to have a look at what it means to factorize. Now, in our previous work with numbers, we've looked at factors, or in fact, highest common factors between numbers. And that's what my first example shows. What's common between our terms, which are two constant terms, 7 and 14? Now, we know that these are both multiples of 7. So it means that 7 is a common factor. So 7 is our common factor, and in fact our highest common factor. But when we start introducing terms that involve numbers and variables, we have to consider what numbers have a common factor and if there are any variables that are common. Let's take a look at example 2. We've got the term 4b and the term 10a. So when we talk about what's common between them, let's first consider the numbers. 4 and 10 both have common factors of 2 and no other common factor. So our highest common factor is going to be 2. Now they both involve variables, but they both involve different variables. So the only thing that's common between them, the only factor, is 2. In our third example, we have 3 terms, 5a squared, 10ab, and 15a. So looking at the numbers, which are the coefficients of these terms, we've got 5, 10, and 15. So they all have 5 as the highest common numeric factor. And the other thing now we can have a look at is their variables. And we can see we've got a's involved in each one. Our first term is in fact 5 times a times a. So in fact, in each of these we have an a that we can consider a common factor. So that means our highest common factor for these 3 terms is 5a. By identifying factors, and in fact the highest factors, allows us to factorize or take out the common things between terms in an expression. For expressions, what we try and do is essentially remove or take out or divide from each term the common factors, and then the remaining parts are placed into a bracket. So when we take out a common factor, we're dividing. So let's see this in action. Our first example is 4a plus 20. So I can see that 4a is represented by 4 lots of a, and 20 can be represented by 4 times 5. So I can see that 4a and 20 have a common factor of 4. So I'm going to place this out the front, and I'm going to open up a set of brackets. So inside the brackets, I'm going to take a look at each term and have a look at what's remaining. Well, if I've got 4a and I've divided it by 4, I'm left with 1a. And 20, when I divide 20 by 4, I'm left with positive 5. And then I can close my bracket. And I can see those remaining parts when I just write them out as an expansion so you can see where they've come from. Now, as a mathematician, we know that we don't need to write the coefficient of 1 in front of a letter, so I can simply write that as 4 bracket a plus 5. Now, from our experience with expanding, we know that we can remove the brackets by expanding, by multiplying every term by 4, and that will get us back to our original expression. Let's try our second example. We've got 6t plus 16. So 6t is just 6 times t, and 16 can be written as 2 lots of 8. So far, writing like this, I can see that we don't have a common highest numeric factor of 6, but I know I can break down the number 6 into 2 times 3 times t, and 16 is 2 times 8. So I can see that I've got a common numeric factor of 2. So I'm going to place that factor out the front, and I'm going to open my brackets. So 6 divided by 2 leaves 3, which I've got here, and I also have a variable of t involved, which I can't forget, and 16 divided by 2 is going to leave that positive 8. And here I have factorised 6t plus 16, highlighting a common factor between those two terms. So this is called factorised form. And then when we go through and we expand by multiplying the 2 back into each term, when we get back to our 6t plus 16, this is called our expanded form, which we have seen previously. So let's see this in action a couple more times. So we're going to factorise the following. So 12p plus 9, I have a common factor of 3, so I'm going to divide 3 into each of those. That will leave in our first term 4p, and in our second term positive 3. In part B, we've got 25 subtract 30t. So I'm just looking at the constant term and the coefficient here of negative 30. So I've got 5 as a common factor. So 25 divided by 5 leaves 5, and negative 30t divided by 5 will be negative 6t. In part C, I've got 14m squared, take 21m. A reminder that 14m squared is 14m times m. So here I'm going to look at my coefficients. I've got 14 and negative 21. 7 goes into both of those, so I'm going to divide each of those by 7. And that in our first term is going to leave a 2. But what I also notice is that I've got a factor of m in each of those. I can take out a factor of 1m in each of those. In my first term, that's going to leave 1m remaining. So negative 21 divided by 7 will leave negative 3, and I've already taken out that factor of m. So my factorised form is 7m multiplied by, in brackets, 2m take 3. In my last example, I've got negative 28y subtract 12. Now I notice here I've got some negatives. When I've got two terms that are negative, I tend to put the negative out the front. And negative 28 and negative 12 have a common factor of 4. So I'm actually going to make my common factor negative 4. So negative 28 divided by negative 4 leaves 7, and this term also has a variable y. Our second term doesn't have a variable because it's a constant, so we're just going to have a number. Negative 12 divided by 4 is positive 3. So my factorised form is negative 4 multiplied by, in brackets, 7y plus 3. So now it's your turn. I'd like you to pause the video and have a go at the following questions. Okay, let's take a look at the following answers in factorising. In our first example, 5 was our common factor. So 5x divided by 5 will leave 1x, and I don't need to put the 1 on the x. And 15 divided by 5 is positive 3. In part B, common factor between 12 and negative 9 is 3. So 12 divided by 3 leaves the 4 in the brackets, and negative 9t divided by 3 will leave negative 3 and the variable t. In part C, we notice that we've got common factor of 4 between 8 and negative 12, but we also have a common letter of m, or variable of m, so we can pull that out the front as well, and that will leave in the bracket 2n subtract 3. And in part D, I've taken out a common factor of the negative and the common factor of 2, and that will leave in our bracket 8y subtract 7, 8y plus 7 because negative 14 divided by negative 2 will leave a positive 7. So just very, very careful when we're taking out that negative. In the challenge question, I can see that negative 24 and positive 16 have a factor of 2, have a factor of 4, but the highest common factor is in fact 8. So here I've got a choice. I can take out a factor of 8 as the number. I also can take out 1x, and I can also take out a y. Remembering that this is negative 24x times y, and positive 16x times y times y. So I've taken out x's as a factor and a y as well. So if we have a look what's left, I can end up with negative 3 because negative 24 divided by 8 is negative 3, and I have an x remaining. And 16 divided by 8 is positive 2, and I have a y remaining in that bracket. Another choice is for us to take out a common factor of negative 8. And if I do that, we'll end up with positive 3x and negative 2y in the bracket. So my challenge for you is to have a look at the following situation. I've got a bit of a problem here. A couple of years ago, I had this lovely question that I had put the solutions into. I asked on the left 4 questions to expand the following expressions, and I had typed up the solutions on the right. Unfortunately, I have some ink stains that have covered some of the questions and their solutions. So I'm trying to find what was my original factorized questions that I expanded. So your task is to work out what's underneath those ink stains, using what you can see for each question to see if we can solve the mystery. I'd love you to have a go at that and bring your solutions to class for our next lesson.